So now we're going to move on to the completeness axiom. This axiom states that there's a real number corresponding to every point on the number line, and for every point on the number line there's a corresponding real number. Based on this axiom, we can say that the sets of real numbers and rational numbers each have no holes. What this means is that between every two real numbers or rational numbers that you choose, there is always a real number or rational number that's in between those two. So the intermediate value theorem uses the completeness axiom in its proof. Although we're not going to prove this theorem, we are going to learn what it is and how we can use it to our advantage. This theorem states that if the function f is continuous for all x in the closed interval a, b, and y is a number between f of a and f of b, then there's a number x equals c in a, b for which f of c equals y. So a picture might help you understand a little bit more about what this is saying. So let's say we have a function f that looks like this, and a, b are 2 points here. F of a is about right here, and f of b is about right here. So let's say y is a number between f of a and f of b. So y is over here. Then there's a number x equals c in a, b for which f of c equals y. Notice how function f is continuous, by the way. So now that we know that y is in between f of a and f of b, then there's a number x equals c, so if we draw a dotted line, we know that c is about right here. So f of c corresponds to a y value in between f of a and f of b, and c is in between the interval a and b. So the important thing about this intermediate value theorem is that the function has to be continuous for all the x values in the closed interval. This theorem is an example of an existence theorem. It tells you that a value x equals c exists, but it doesn't tell you what c equals. That you have to find out by yourself.